Hi everybody, welcome to our section 4.3 lecture video on multiplying and dividing sign fractions. So we're going to start off with multiplying fractions. So how you multiply fractions is pretty straightforward. You would just multiply straight across. You multiply numerator times numerator. And you multiply the denominator times denominator. Okay. The thing is, though, that you're going to need to answer in simplest form. So you need to simplify those fractions. And you can either simplify before multiplying, or you can simplify after multiplying. And how you do that is exactly the same way we did it in our last section. And it's by dividing common factors in a numerator and a denominator. So dividing a numerator and a denominator by a common factor. So down here I do have a quick visual so you can see what it looks like to multiply fractions. So multiplying, a good way of thinking of that is an area model. So that would be like length times width of a rectangle. So I've got 1 unit this way, 1 unit that way. So this is 2/3 times 1/2. So 2/3 would be 2 of the 3/3, and 1/2 would be 1/2 of a unit. So if you multiply 2/3 times 1/2, you would get this shaded area right here, which would be 2 of the 6 boxes now. Or you could think of that as 1/3 if you want to simplify that fraction. So let's practice these a little bit. In example 1, I've got 5/8 times 7/9, and I need to multiply those together. So for simplifying, what I like to look at, I actually like simplifying before, because then I don't miss anything, and I think it's a little bit simpler with the arithmetic. So I see a 5 in the numerator, and I think, would it simplify with an 8? No, 8 isn't divisible by 5. Would it simplify with the 9? No, 9 isn't divisible by 5 either. How about the 7? Is 8 divisible by 7? No. Is 9 divisible by 7? No. So there's actually no simplifying we can do in this one. We're just going to go ahead and multiply it. So 5 times 7 is 35. 8 times 9 is 72. And so they multiply to give you 35 over 72. In part B, I have 2x squared times 1/4. If you have something like this where it doesn't look like it has a denominator, the denominator is actually 1, if it helps to kind of put it into a fractional form for you. So the 2x squared is only in the numerator. So simplifying, I notice that 2 and 4 are both divisible by 2. So what I'm going to do is simplify first by dividing both of those by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. Then what I have is 1x squared times 1, which would be x squared in the numerator. In the denominator, I have 1 times 2, which would be 2. So my answer is x squared over 2. In part C, I have 2/3 times 0, and anything times 0 is 0, including fractions. So 2/3 times 0 would be 0, and that was pretty quick. In part D, I have negative 5x over 2 times 18 over 15y. And I notice quite a bit that I can simplify. I notice 5 and 15 are both divisible by 5. One is in a numerator, one of those is in a denominator, so I can simplify that. I can divide the numerator by 5. 5 divided by 5 is 1. I can divide the denominator by 5. 15 divided by 5 would be 3. The other thing I notice is the 2 and 18 are both divisible by 2. and one of them is in a numerator, one of those numbers is in a denominator. So I can divide them by 2 and simplify the fraction. 2 divided by 2 would be 1. 18 divided by 2 would be 9. And now what I have is 1x times 9, which would be 9x. In the denominator, I have 1 times 3y, which would be 3y. I have a negative times a positive, which would be a negative. And from here, what I notice is that 9 and 3 are both divisible by 3, so I could actually keep going and simplify it a little bit more. It's always good to do that check of, can I simplify some more, because you wouldn't want to leave anything out. Let's see, negative 9 divided by 3 would be negative 3. So now I've got a negative 3x. 3y divided by 3 would just be y. So my answer is negative 3x over y. E looks really fun because we have 3 fractions multiplied together. And the nice thing is that once you multiply, everything in the numerator is part of a big numerator. Everything in the denominator is part of a big denominator. So you can actually simplify across fractions if you would like to. As long as one of those things is in a numerator and one is in a denominator, you can simplify. So let's see what all we see here. I see a 3x squared and I see a 15z. 3 and 15 are both divisible by 3. So I'm going to divide by 3. 3 divided by 3 is 1. I'm going to divide by 3. 15 divided by 3 is 5. Next thing I notice is x's. I notice that there's an x squared in the numerator and an x in a denominator. So I can divide by one of the x's. So if I divide by x, instead of having x squared, I'm just going to have x to the first, or x. Instead of having an x here, I don't have one anymore. I've divided it out. Let's see, I have a 7y in the numerator and a 14y in the denominator. 7 and 14 are both divisible by 7. So I can divide by 7 and get 1. Divide by 7 in the denominator and get 2. I can also divide by y. Divide by y and divide by y. And now our y's have simplified out. Next up, I notice 8 and 10 are both divisible by 2. So I can divide the 8 by 2 and get 4. Divide the 10 by 2 and get 5. I could actually do that again because now 4 and 2 are both divisible by 2. I could divide the 4 by 2 and get 2. I could divide this 2 by 2 and get 1. I think that's everything, so let's go ahead and multiply it out. If you ever get to a point where like, I don't know if I'm done or not, go ahead and multiply them together. And you can always do like we did in part D and simplify one more time if you need to. So from where I am here, I've got a 1x times 1 times 2. So that would be 2x in the numerator. I have 1 times 5 times 5z, which would be 25z in the denominator. Looking at the sign, I have a negative times a positive, which would be a negative. And then that negative times this negative would be a positive. So I have a positive 2x over 25z as an answer. And one little note here, if you guys were wondering, why didn't she simplify the 5's? It's because they're both in the denominator. And remember, to simplify something, one is in a numerator, one is in a denominator to simplify. Otherwise, they actually multiply together. They're not going to divide out. Let's see, in part F we have exponents. So let's go ahead and write that out so we know what we have here. So we have negative 2/5 to the third. So that's negative 2/5 multiplied by itself 3 times. And then that is multiplied by 5/12. So let's do some simplifying. It looks like I can divide by a 5. So 5 divided by 5 would be 1. Then with the 12 and 2, they're both even. They're both divisible by 2. So 12 divided by 2 is 6. 2 divided by 2 is 1. I could do that again because now I have a 6 and a 2, which is also divisible by 2. So divide by 2 and I'll get 3. Divide by 2 and I'll get another 1. I think that's everything, so let's go ahead and multiply stuff out. So I've got a 2 times 1 times 1 times 1, which is 2. And the denominator, I've got 5 times 5, which is 25, times 1, which is still 25, times 3, which would be 75. And then let's look at the signs. Negative times negative is a positive. Then that positive times another negative is a negative. And then that negative times a positive is a negative. So our answer is negative 2 over 75. So there's a good grouping here of multiplying examples. So hopefully that helps you guys with multiplying. Next up is dividing. So dividing fractions is the same as multiplying by the reciprocal. Which I know is a very fancy math word, for the multiplicative inverse, which is another really fancy math word. But what it looks like is actually pretty simple. The reciprocal just looks like a fraction where the numerator and denominator are switched. So it's really not that bad to do. It's just a fancy word. So let's practice that a little bit. So with these division problems, the first thing I'm going to do is write them as multiplication problems, and then they're going to work exactly the same as what we've been doing. So the first one I have is 3/5 divided by 4 over 7x. So writing that as a multiplication problem, we still have 3/5, but instead of division, I'm going to change that to multiplying by the reciprocal. So I'm going to multiply by the reciprocal of 4 over 7x. The reciprocal of 4 over 7x is 7x over 4. So the reciprocal always has the numerator and denominator switched. That's what they look like, okay? Now that we've changed it to a multiplication problem, we can look about, can we simplify that one? Just looking here, there's no simplifying to do. So we can go ahead and multiply straight across. 3 times 7x would be 21x. 5 times 4 is 20. And I know some of you, that's going to make you cringe because it's an improper fraction. Leave it, okay? Please. If you guys start splitting these up, especially with variables in them, it starts messing the problem up. So just leave them as improper. They're fine. I promise improper fractions are wonderful things. And you can leave them like that, okay? The next one I have is negative 8 over 15y divided by 12 over 18y. So if I want to write that as a multiplication problem, I'm going to keep the first fraction as it is. It's negative 8 over 15y. But I'm going to change it from division to multiplying by the reciprocal. So I'm going to do multiplying by, and this would be 18y over 12. Then I can see if I can simplify it all. So simplifying, I notice that 8 and 12 are both divisible by 4. So 8 divided by 4 would be 2. 12 divided by 4 would be 3. Then 15 and 18 are both divisible by 3. So 15 divided by 3 would be 5. 18 divided by 3 would be 6. And then I can also divide out the y's. So divide by y and divide by y. And then what I'm going to have after all of that would be 2 to 6, which would be 12. 5 times 3, which would be 15. And a negative times a positive would be a negative. And then I notice I can actually simplify some more because 12 and 15 are both divisible by 3. 12 divided by 3 would be 4. 15 divided by 3 would be 5, and it's still negative. Our answer is negative 4/5. Last one I have over here is 27x over 14 divided by negative 3x to the third. So if I want to write this as a multiplication problem, it would be negative 27x over 14 times the reciprocal. So the reciprocal for this one, if it helps, this is really over 1. So your reciprocal would be negative 1 over 3x to the third. Then we can look and see, can we simplify? And I can a little bit. 27 and 3 are both divisible by 3. So 27 divided by 3 is 9. 3 divided by 3 is 1. I can also divide out one of the x's, so I can divide by x and get rid of this one. I can divide the x to the third by x, and now I would have x squared. Then multiplying straight across, 9 times 1 is 9. 14 times x squared is 14x squared. And a negative times a negative is a positive. Okay. Hopefully this helps you guys with some division and multiplication. Good luck today.